ಆಲ್ಮೋಸ್ಟ್ 60 to 70% ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಡಿಫರೆನ್ಷಿಯೇಷನ್ನು, ಇಂಟಿಗ್ರೇಷನ್ನು ಆ್ಯಂಡ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿ ಈಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್. ಏನಕ್ಕೆ ಅಂತಂದರೆ ಇಟ್ ಇನ್ವಾಲ್ವ್ಸ್ ಲಾಟ್ ಆಫ್ ಫಾರ್ಮುಲಾ ಇನ್ ಇಟ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಮೆಮೊರೈಸ್ ಇಟ್. ಆ ಫಾರ್ಮುಲಾನ ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಳೋದೇ ಒಂದು ದೊಡ್ಡ ತಲೆನೋವಾಗಿ ಹೋಗಿರುತ್ತೆ. ಸೊ ಅದನ್ನೆಲ್ಲ ನೆನಪಲ್ಲಿ ಇಟ್ಕೋಬೇಕು ಅಂತಂದರೆ ಯು ಶುಡ್ ಹ್ಯಾವ್ ಸಮ್ ಟ್ರಿಕ್ಸ್, ಯೂಸ್ ದಟ್ ಟ್ರಿಕ್ಸ್ ಆ್ಯಂಡ್ ರಿಮೆಂಬರ್ ದ್ಯಾಟ್. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಆಲ್ರೆಡಿ ಐ ಹ್ಯಾವ್ ಮೇಡ್ ಒನ್ ವಿಡಿಯೋ. ಐ ವಿಲ್ ರೆಕಮೆಂಡ್ ಯು ಟು ವಾಚ್ ದಟ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿ ವಿಡಿಯೋ ಫಸ್ಟ್, ಬಿಕಾಸ್ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಆ್ಯಂಡ್ ಇಂಟಿಗ್ರೇಷನ್ ಇನ್ವಾಲ್ವ್ಸ್ ಲಾಟ್ ಆಫ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿ ಫಾರ್ಮುಲಾ ಇನ್ ಇಟ್. ಸೊ ಆಲ್ಮೋಸ್ಟ್ 1 hour ವಿಡಿಯೋ ಇದೆ, ಆಲ್ಮೋಸ್ಟ್ 50 to 60 ಫಾರ್ಮುಲಾ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದ ಟ್ರಿಕ್ಸ್ ಇದೆ. ಸೊ ಗಿವ್ ದ ಲಿಂಕ್ ಇನ್ ದ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಸೊ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ವಾಚ್ ಇಟ್ ಆ್ಯಂಡ್ ಲೇಟರ್ ಯು ಕ್ಯಾನ್ ಜಾಯಿನ್ ದಿಸ್ ವಿಡಿಯೋ. ನೌ ಲೆಟ್ಸ್ ಗೆಟ್ ಸ್ಟಾರ್ಟೆಡ್. In this video, we are going to study about the formula of differentiation and integration on the same slide. We are going to compare the integral formula and differential formula on the same slide, and we will remember with the help of the tricks. Here the first set of formula is based on the exponents, and the remaining sets are based on trigonometry, and next set is based on inverse trigonometry. In this way we are going to study here completely differentiation side on the left side, and right side it is integration. So this is the first rule called as power rule. Power means there is n as a power here. Derivative of x to the power n with respect to x is n x to the power n minus 1. But integral of x to the power n dx is x to the power n plus 1 divided by n plus 1 plus c, where c is integral constant. Here you can just compare. Here you have multiplied n, but here you have divided the n, and here n minus 1 is there and here n plus 1 is there. But important condition is that n should not be equal to minus 1. If n is equal to minus 1, that time it becomes x to the power minus 1. That time we have to use this formula, that is log x formula. Here integral of 1 by x, this is what we have to use it, because if you put n is equal to minus 1 here, the complete term will vanish. That is why n should not be equal to minus 1. Now let us solve some problem based on these two set of formula so that we can understand even more better. Differentiation of x to the power 5. So let us apply this formula. So n value is 5 here. So 5x to the power 5 minus 1. So that gives you 5x to the power 4. Let me take the second example. Differentiation of x to the power 2024. So this is 2024 n x to the power n minus 1. So 2023. And the third example, d by dx of x. If nothing is there, that means 1 is there. So this is n x to the power 1 minus 1. So that gives you x to the power 0. X to the power 0 is nothing but 1. So you should know any number to the power 0 is always equal to 1. So any number to the power 0 is always equal to 1. And next one, fourth example. What is the differentiation of 1 divided by x? If nothing is there means 1. So this is differentiation of, we can write it like this, x to the power minus 1, right? So here the n value is minus 1. So we can do it minus 1 x to the power minus 1 minus 1. So we can write it like this. So minus 1 x to the power minus 2. That gives you minus 1 divided by x square. See, this This is a general formula of differentiation of 1 by x. So differentiation of 1 by x is minus 1 by x square. This is an identity, we have to remember it. And next one, fifth one, differentiation of root x. So this is also one identity, we have to remember it. So we can write root x as x to the power half. So we can write n x to the power n minus 1. So n x to the power half minus 1. Half minus 1 is minus half. So we can write 1 divided by 2 x to the power plus half. That gives you 1 divided by 2 root x. So this is also an identity. So in differentiation of root x is 1 divided by 2 root x. Let me give you one more formula, that is useful formula, that is not given in any textbook. That is differentiation of 1 by x to the power n. So here it is differentiation of x to the power n, but this is differentiation of x to the power 1 divided by x to the power n. That is minus n divided by x to the power n plus 1. This is a useful formula. One example based on this is, what is the differentiation of 1 divided by x square? This is minus n, that is minus 2 divided by x to the power n plus 1. So 2 plus 1, that is 3. Now let us solve some problems on integration power rule. So let me take the first example. Integral of x to the power 5 dx. So I'm going to apply this formula now. So this is x to the power n plus 1. So 5 plus 1 divided by 5 plus 1. That gives you x to the power 6 divided by 6. Plus c. C is integral constant. And second one, integral of root x dx. And this is looking like integral of x to the power half x. So that is equal to n x to the power n plus 1 divided by x n plus 1. So x to the power half plus 1, that is 3 by 2 divided by n plus 1, that is 3 divided by 2, and that 2 will come to the numerator, so 2. And let me take the next one. What is integral of x to the power 2024? This is x to the power 2025 divided by 2025 plus c. Here also plus c is there. And next one, what is integral of root x? Integral of root x is over integral of x dx. If nothing is there, 1 is there. So x to the power 1 plus 1, that is 2 divided by 2 plus c. And let me take the next one. What is the integral of 1 divided by root x? So we can write it like this. So this is x to the power minus half. So that gives you x to the power n plus 1. n plus 1 divided by n plus 1. So that gives you x to the power minus half plus 1 is only half, and divided by minus half plus 1 is, that is also half. So 2 will come to the numerator. So 2x to the power half can be written as root x. See, this is an identity. So integral of 1 by root x dx is 2 root x. And plus c is there always. And here this can be written as, this is also an identity. We can write it like this. So 2 divided by 3 x to the power 3 by 2 can be written as x to the power 1 x to the power half. So that gives you 2 by 3 x root x. So integral of root x dx is 2 by 3 x root x. So this is also an identity. We have to remember it. Let me give you one more formula that is not so famous but very important one. That is integral of 1 divided by x to the power n dx. So that is equal to minus 1 divided by n minus 1 x to the power n minus 1. Plus c is always there. Let me give you one example for this. What is the value of 1 divided by x square dx? So this is minus 1 divided by 2 minus 1, that is 1. So x to the power 2 minus 1, that is 1 itself, plus c. So integral of 1 by x square dx is minus 1 by x. Now let us see the next formula, that is exponential function. Derivative of e to the power x is e to the power x. Integral of e to the power x is also e to the power x, plus c is there. And this is one kind of special function. Derivative of e to the power x is also e to the power x. It is not going to change. And integral of e to the power x is also e to the power x. It is not going to change. See, e is called Euler's function and its value is always constant, that is around 2.718. But next one you see, this is not e, this is a. A may be any arbitrary number. Okay, but e is not that one. It is a constant, that is 2.718. And the next one is derivative of a to the power x is equal to a to the power x log a base e. But integral of a to the power x is almost same, a to the power x, but here you have to divide log a, plus c is there. Here we have multiplied log a and here we are dividing log a. If e is not given anywhere, that is understood that e is there. And the next one, derivative of log x is 1 by x. And the reverse process, integral of 1 by x is log x. See, both are reverse process. Integration and differentiation are reverse process. And these are called as derivatives. Differentiation is called as derivatives and integration is called as anti-derivatives. Okay, next set of is based on trigonometry. ಇದಕ್ಕೆ ಟ್ರಿಕ್ಸ್ ಯೂಸ್ ಮಾಡೋಣ. Here you see I am going to write sin cos, tan sec, cot cosec. Okay, separate ಆಗಿ ಈ ತರ ಬರ್ಕೊಳ್ಳಿ. And now later we will use the trick. You just cross mark like this. This cross mark indicates this cos should go here and sin should come this side. And here also you mark it. And here also you mark it. This is the first step. And second step is you just identify the function starting with c. So here c is there and here also c is there and here also c. Wherever c is there, you write the negative sign. Here also negative and here also negative. Okay, now you just mark it. So cos should go this side, cos x, and sin should come this side, sin x. And here sec should come up and tan should come down. But it is not completed yet. I will tell you later. And cosec should come here, cosec, and here it is cot. We have crossed this. Okay, now only for these two, tan and cot, you have to mark again like this. Let me mark it. So in this way. That means sec should go here also. Sec x into sec x, that becomes sec square x. And that sec should come here also. Tan x into sec x. Or sec x into tan x. And here again you have to mark the same way. Cosec should go up also. So cosec square x. And here also cosec should come. So cosec x. So derivative of sin x is cos x and derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of sec x is sec x into tan x. Derivative of cot x is cosec square x with negative sign. And derivative of cosec x is cosec x into cot x with negative sign. Now antiderivatives we will write. Antiderivative means integral of cos x, that becomes sin x here. So if you take the integral of this, you will get the sine. That's what we will see now. So integral of cos x is sin x plus c. C is always there. And next, derivative of cos x is minus sin x, we have written already, and here minus cos x plus c. And integral of sec square x is tan x plus c. See, that is this one. And next, integral of sec x into tan x is sec x. And next one is integral of cosec square x is, since negative sign is here, you just identify that. That also should come this side. So minus cot x plus c. And next one is integral of cosec x into cot x is minus cosec x plus c, because negative sign is already there. Okay. Okay, next one about the inverse trigonometric functions. These are the next set of formula based on inverse trigonometry. Derivative of sine inverse x is 1 divided by root 1 minus x square. And derivative of cos inverse x is minus 1 divided by root 1 minus x square. See, negative sign ಇಲ್ಲಿ ಬರ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, so this function is started with c ಅಂತ ಅರ್ಥ. But integral of this function, that is equal to sine inverse x, and integral of this function is minus ಇರೋದ್ರಿಂದ minus will be shifted on the other side, so that is minus cos inverse x. And next one, and these are important in maths, derivative of tan inverse x is 1 divided by 1 plus x square, but its integration is tan inverse x. And derivative of cot inverse x is, c is there here, that is why it is starting with negative sign. c ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇದ್ರೆ ಯಾವುದೋ ಒಂದು ಫಂಕ್ಷನ್ ನೆಗೆಟಿವ್ ಸೈನ್ ಬರಿಬೇಕು. ಸೊ 1 divided by 1 plus x square, but integral of this function becomes minus cot inverse x, because they are antiderivatives. And next one, derivative of sec inverse x is 1 divided by x root x square minus 1. ಇಲ್ಲಿ 1 minus x square ಇತ್ತು, but here it is x square minus 1, but x is also there. But integral of this function becomes sec inverse x. And similarly, c in the start ಆಗ್ತಾ ಇದೆ, that is derivative of cosec inverse x. So minus 1 divided by x root x square minus 1. See, both are same almost, and these two are also same, and these two are also same, but negative sign is there. Okay. And its integral is minus cosec inverse x. So here you can observe there are two formula for integral of 1 divided by root 1 minus x square, that is sin inverse x, as well as minus cos inverse x. Integral of 1 divided by 1 plus x square is tan inverse x, as well as minus cot inverse x. Integral of 1 divided by x root x square minus 1 is sec inverse x, also minus cosec inverse x. And now the next one is derivative of constant. Derivative of constant is always 0, but integral of constant is not 0. Integral of constant is constant into x plus c. Let me give you one example here. What is the integral of 1 dx? This is only x plus c is there. And what is the integral of 2 dx? See, it is a constant, no? Constant should come out. So that is why it is 2x plus c. And what is the integral of, let me write it, pi d theta. That time pi is constant, it should come out. So pi, and integral of d theta is just theta plus c. And the next one is derivative of constant into x. That is just k. Because the derivative of x with respect to x is 1 and k into 1 is just k itself. And let me take an example for integration also here. The integral of kx dx is equal to, k is constant, it will go out. So we can write it as k into integral of x dx. That gives you k into integral of x dx is x square divided by 2 plus c. Okay, we have used this first identity. So x to the power 1 plus 1 divided by 1 plus 1. That is x square by 2. See, in this slide there is no integral of tan x, integral of cot x, integral of sec x and cosec x. So that we will list out in the next slide. That is the first one. Integral of tan x dx is log of mod sec x plus c. And one more formula, negative log of mod cos x plus c. Mod indicates that the log have only positive values. Okay, log positive value matra baribeko, so negative value it will not accept. That is why mod. But how you got this negative sign here? As you know, this sec x is nothing but a reciprocal of cos x, and if you shift it to the numerator, cos x to the power minus 1 anta barutte. And if you take the log of this, so log cos x to the power minus 1 antandre, we have to shift this minus 1 here. So that gives you minus 1 into log cos x. So this is the rule of log. Okay, power should come here. So that is what is log cos x. And if you take the derivative of this, do you get this tan x or not? We will check it, because integration and derivatives are a reverse process. Okay, if you solve it and keep it ready, you will never forget it. ಅದಕ್ಕೆ ನಾವು ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ನೆನಪಲ್ಲಿ ಇಟ್ಕೋಬೇಕಾಗುತ್ತೆ ಫಾರ್ಮುಲಾನ. So let me take the derivative of this. So if I take the derivative of this term, so what you are going to get? Negative sign is there. So negative derivative of log cos x. So we have to apply the chain rule here because two functions are there. So minus log x, it is looking like log x. What is the derivative of log x? That is 1 divided by x, but x value is here cos x. Cos x na x anta consider ಮಾಡಬೇಕು, chain rule apply ಮಾಡಬೇಕಾದ್ರೆ. And later, what is the derivative of cos x? That is minus sin x. I have applied the chain rule, and minus minus will go and you will get tan x. Sin x divided by cos x is tan x, and that is the tan x here. So integral of tan x is negative log mod of cos x, and log sec x is also a formula for it. Let us move on to the next one. That is also same way. That is integral of cot x. Integral of cot x is log sin x. As you know, cot x is cos divided by sine, right? Cot x is cos divided by sine. Okay, ಅದಕ್ಕೋಸ್ಕರ sin ಬರುತ್ತೆ ಇಲ್ಲಿ. But tan x ಗೆ ಆ ಥರ ಅಲ್ಲ. Tan x is sin divided by cos. That is why cos is here. And one more formula is there for this. That is equal to, as sin x is reciprocal of cosec x, so we can write it like this, minus log cosec x plus c. This is also a formula with mod, because log accepts only positive. ಈ ಥರ ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಫಾರ್ಮುಲಾ ಏನಾದರೂ ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ನಾವು, okay, there is a less chance of forgetting the formula. So that is why we have to solve it once and remember the formula. And let us move on to the next one, that is integral of sec x dx. That is log of sec x plus tan x plus c. Now last slide allo nodidivi, sec and tan always come together. That is derivative of sec x is sec x into tan x, that we have seen in the last slide. So one more formula, and this question has come in JE directly of maths. So that is integral of sec x is equal to log of mod tan x by 2 plus pi by 4 plus c. And one more, integral of cosec x. See again, cosec x and cot x should come together. Okay, c ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದೆ ಇಲ್ಲಿ, ಆ ಥರ ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ. ಸೊ log of mod cosec x minus cot x plus c, and one more formula is log of mod tan x by 2 plus c. Let us move on to the next one. Okay, these are the important identities, and these two formula are looking similar to the previous slides what we have studied. If you put a is equal to 1 in these two formula, you will get important identity that we have studied already in previous slide. So that gives you tan inverse x. So integral of 1 by x square plus 1 is tan inverse x. And if you put a is equal to 1 here, you are going to get integral of 1 divided by root 1 minus x square. That is equal to sin inverse x. We have already studied this in previous slide. Since it is looking similar to it, that is why tan inverse is coming here. So 1 by a tan inverse x by a, and here there is no 1 by a, only sin inverse x by a plus c. And the next two formula is looking like this, integral of 1 divided by x square minus a square dx, and integral of 1 divided by a square minus x square dx. Here first you have to write 1 by 2a log, 1 by 2a log. And since a is negative here, so x minus a divided by x plus a you have to write. But a value is positive here, so that is why you have to write a plus x divided by a minus x. And the next one, two more set of formula, integral of root x square plus a square and integral of root x square minus a square. Here first you have to write log mod x, and later you write this denominator here. That's it. And the next one, these are important in mathematics and not that much of important in physics. So this is integral of root x square minus a square dx, and integral of root x square plus a square dx, and integral of root a square minus x square dx. Now first you have to write x by 2 for everything, and later whatever here it's there, you just repeatedly write. Okay, and next minus a square by 2, since minus is here, write minus a square by 2, plus is here, write plus a square by 2, and here again a is plus. Okay, that is why plus a square by 2 you have to write, and continue. So this is log x, you write it first, plus whatever you have written here, you repeat that. That's it. And next one, so it is slightly different. So sin inverse x by a should come plus c. Okay, these are the important formula, whatever required for the physics we studied. Many more formula are there that is not required for the physics.